Hi, for this video we're going to use the TI-Nspire graphing calculator to help us run a hypothesis test. The situation we have here is a consumer group claims that the mean annual coffee consumption in the US for one person is 23.2 gallons. A random sample of 70 people in the US has a mean annual coffee consumption of 21.6 gallons. Assume the population standard deviation is 4.8 gallons, and at a 5% level of significance, can you reject the claim? So what we're going to do is the first thing is we've got to figure out which hypothesis test we want to use. And the way that we tell is we look for the population parameter that we're studying. Since we have the mean, that tells us that we're going to do a hypothesis test for the mean. We only have a single mean, so that tells us that we're either going to use the z-test or the t-test. Remember, the difference between the two is a z-test you use if you know the population standard deviation, and the t-test we use if we know the sample standard deviation. So if we read through here, it tells us the population standard deviation is 4.8. So since sigma is known, we know that it is 4.8. That leads us to believe that we're going to be able to use the z-test. So the z-test is the one that we use for the mean when we know the population standard deviation. Remember, in order for the central limit theorem to kick in, which is something that is important in hypothesis testing, you do have to have a sample size that is greater than or equal to 30. In this case, we have n equals 70. If we do not have a sample size that is greater than or equal to 30, then we have to have a normally distributed population. If it's not normally distributed, then it will not kick in. The other thing that we have to have is a random sample, and it does tell us that we had a random sample. So we can use the z-test. There are some additional conditions that are stated in some other textbooks, so just make sure that you check with your text. The text that I'm teaching from currently, these are the conditions that must be used in order to perform the hypothesis test. But I have taught from other textbooks where they have slightly different conditions. They all have this one for sure, the greater than or equal to 30 and the random sample, but some of them state things just slightly differently. So make sure that you check your textbook. Once we know what kind of test that we are going to perform, then we have to set up our null and our alternative hypotheses. The null hypothesis 100% of the time must contain equality. The alternative must contain inequality. So if we look at this, when we look at our claim, it says that the mean annual coffee consumption in the US is 23.2. So since it says is, that means equals. So we would say that mu equals 23.2. The opposite of equals is mu does not equal 23.2. And I always just write down which one my claim is about because sometimes this changes. And so since our claim is about the null hypothesis, we would look at the alternative hypothesis to help us determine the tail of the test. So this gives us a two-tail test, which means when we draw our model, we must shade both tails. So if I draw out my model, you can center this either at the mean that is given, the population mean, or you can center it at 0 and then find your standardized test statistic. So the standardized test statistic for this is z equals x bar minus mu divided by sigma over square root of n. And this is programmed into your calculator. So as long as you have the information to plug into your calculator, it will find it for you. But if you have to show work, then I would plug all the information in. So in order to use this formula, we have to know the sample mean. And so let's go ahead and write that down. The sample mean is 21.6. The population standard deviation was 4.8. The sample size is 70. And the alpha that we are using is 5%. So those are the things that we have to know in order to run the test. So let's plug in all of our values. X bar is 21.6. The mean is 23.2. And then we would have 4.8 divided by the square root of 70. And like I said, your calculator is doing this entire calculation for you when you run the z-test in your calculator. So what we're going to do is I'm going to open up a calculator screen. So I'm just going to go to a calculator screen and hit Menu and go to Statistics, which is option 6. And then I'm going to choose option 7, which is the Stats test, and option 1, which is the z-test. And then it's going to ask you, do you have the data? If you have the data to put in a spreadsheet, that's what you would use that for. But we have the statistics. We already know what the sample mean is and the sample size. So the first thing it asks you for is mu naught. Mu naught is always your hypothesis. So we would put in the 23.2. We're starting with that the mu naught is 23.2. And we always start out with the assumption that the null hypothesis is true, and then it's the sample's job to show that it is not true or that it is true. The next thing that we have is sigma. So it wants to know what is our population standard deviation. So I would use 4.8. X bar comes next, so we would put in our 21.6. And then it asks for our sample size. And then the last thing that we have to do is we have to decide whether we have a two-tail test, a right tail, or a left tail. So whatever the alternative hypothesis is, the one that you would select. And then you click OK, and all of your information comes up here. The X bar, it gives it to us as negative 2.78887, and I was not watching when I put the decimal. So that was 2.7887. So if we were looking up a table to find our p-value, we would see that negative 2.78 is really not very much area. It would be down here. And I'm just going to round it to 9. And then remember that we have to shade both sides. Our particular test statistic falls down here, but because it's a two-tail test, since it's not equal, we do have to shade both sides. Basically, we're looking for the probability in both areas. With not equal to means that it can either be less than or greater than in order to reject or fail to reject. So the other thing that we have to look for in this is the p-value. And the p-value is the probability of, based on this distribution, of getting a sample of 21.6, a sample of size 70 with an average of 21.6, if this was truly the mean. So the way that this is calculated is this is really just the probability that our z-score is less than negative 2.79 if I round it. And the probability of this happening is 0.0053. And if you look right here, that is where I got that number from. It tells you the p-value right here. It says p-value and it gives you the answer right here. And then you would compare your p-value to make your decision. We're going to compare our p-value. We're going to compare it to the alpha level. So this has to be determined beforehand. So our p-value of 0.0053 is less than alpha equals 0.05. So anytime that your p-value is less than alpha, you reject the null hypothesis. So we're saying essentially that based on the evidence of this sample, it's strong enough to say that this is not very likely to happen if this was truly the mean. So we're saying that the null hypothesis essentially is not very likely to happen because it only happens 0.53% by chance alone to get this sample. So since we're rejecting the null hypothesis, we are rejecting the claim. So the way that we would write our answer, we would say with 5% level of significance. I cannot type. I'm going to just scrap this and say at 5%. We could say with the confidence level, you could say at alpha equals 0.05. There's a lot of different ways of saying this. We're just going to say at 5%, we have enough evidence. And this really is strong evidence because it's so unlikely to happen, but we have enough evidence to reject the claim that the mean coffee consumption for an individual in the U.S. is 23.2 gallons. So we basically just restate what we originally started with. So at 5%, we have enough evidence to reject the claim that the mean coffee consumption for an adult in the US is 23.2 gallons. And if we wanted to go a little bit further, we could say based on our sample, it appears that the coffee consumption happens to be less than 23.2. Since we had such a strong evidence for this not being true, we could really say that it looks like it's much lower. As always, thanks for watching. Continue to check out all of my video content.